Hello, everybody. Welcome. I'm here to talk today about the use of drones and GIS in river monitoring, and I'll be using the Cache La Poudre River watershed as a case study today. I'm Ben Sellers. I'm a river scientist, and I work with GIS and spatial modeling tools in river restoration monitoring and prioritization. I've been working in river restoration world since about 2019, and in that time I've been a researcher. I've worked on field crews. I've been a statistical modeler, and I currently run a small business, small mapping business out of Fort Collins, helping river practitioners and other environmental groups collect and analyze drone data. So in my time with restoration monitoring, I've come to know really well that measuring success in river restoration is difficult. Rivers are dynamic, budgets are thin, and the time scale of monitoring is often at odds with the time scale of river processes. So I'm here today not to offer drones as a silver bullet to solve all these issues, but to offer them as a cost-effective tool for tracking restoration outcomes and informing decision-making. So here is an overview of my talk today. I'm going to start with introducing drone mapping and drone mapping products, and then highlight the applications of this data from some projects in the Poudre watershed in northern Colorado. And then I'll discuss some opportunities and limitations of incorporating drone mapping into restoration monitoring. So what is drone mapping and how does it work? Well, at its simplest, drone mapping is programming a drone to fly over a site and take a bunch of overlapping images. And these images have spatial the drone has a GPS, so it records the location of these images, and that geographic accuracy can be improved using ground control points throughout the site or an RTK drone. But this data is brought together and processed in specialized mapping software to get really high resolution, high accuracy geospatial layers. So here's an example of what those layers look like. You get a surface model, which is an elevation model of the site, or an elevation map of the site. Think of it very similar to LiDAR, although it doesn't have the same vegetation penetration abilities. It's just mapping the surface. And then the orthomosaic is a very high resolution vertical top-down view of the site. So both of these products are spatially referenced and can be dragged and dropped into GIS and used as a baseline for measurements and monitoring. So with data like this, you have a free alternative, right? Like county LiDAR or Google Earth images. So where does drone imagery come in and why is it useful? Well, I'm going to highlight two main reasons. The first is the resolution. So the resolution of these products is very, very high compared to freely available data. We're talking about a pixel being around 2 centimeters or lower, depending. So it's totally customizable. The resolution is based on how low you fly the drone. So the lower you fly, the more images you take, the higher resolution. And there's sort of trade-offs with how much you could fly at 5 feet and get a crazy high resolution map of the site, but that becomes a little more data intensive. So it's totally customizable and up to you. And because of this, you're able to really inspect these sites for really small scale changes. So you can see wood in channels. You can measure the width of little side channels and detect micro topography, which is really useful in low-tech PBR sites where a lot of these channels are very messy and you have a channel popping out in one area and then going underground and then coming out another. So having high resolution imagery is really useful for monitoring those sites. And then the other reason that drone imagery is so useful is because the timing is fully customizable as well. So this allows you to collect data at times where you're most interested. So some examples might be high water, targeting high flows at a site, and then low flows at a site. You might do pre-restoration and post-restoration, or try to catch a certain invasive plant at a phenologic phase where it stands out. So this combination of high resolution and timely data really gives you a data set that can be useful for planning, monitoring, and adaptive management. So now I'll switch over to talk a little more about the applications and how we're using this drone imagery around Colorado, in northern Colorado specifically. So most of this work is focused in the Cache la Poudre watershed in northern Colorado, and a lot of it has come as a result of the Cameron Peak fire, which burned 200,000 acres in the summer and fall of 2020. So this fire led to a lot of flooding and debris flows, erosion, and up in the higher reaches of the watershed, which led to fish kills and other water quality issues downstream. So in response to this, agencies, nonprofits, and state and local governments have come together to implement a network of low-tech process-based restoration projects with the goals of improving water quality and ecologic function. By increasing roughness, reducing flow velocities, and promoting sediment deposition up at the high elevation sites to kind of reduce the impacts downstream. And the Coalition for the Poudre River Watershed, as well as the Larimer Conservation District, have really been spearheading a lot of this work. So here is just a visual of what some of these projects look like. This is a post-assisted log structure in an high elevation meadow. So this PAL structure is using blocking off flow and helping keep water up on the landscape and create more inundation for longer in the spring. So to plan these projects, engineers and practitioners really need comprehensive site-wide information to really figure out where structures can be placed to have the most benefit. And those surface models that I mentioned earlier are really useful in this planning phase because they reveal micro topography and how where the floodplain can most easily be connected with the use of these PALs. So you can see this is a relative elevation map. So the elevations are in comparison to the water surface elevation. So the darker spots are closer to the water's surface. So that lets you pick out places where just a little rise in water elevation can unlock that floodplain. So having a spatial data layer like this allows practitioners and engineers in the office to plan where structures can be placed using the local topography to their benefit and help let the river do the work in these low-tech sites. So once the structures are out in they're implemented and they're out in the watershed, practitioners really need, they're subject to the elements. So this is high flows are coming through in the spring. There's freeze thaw happening. Beaver activity might be changing some of these structures. So practitioners really need to understand the status of these structures for planning maintenance and adaptive restoration. So having repeat drone maps from year to year gives you a site-wide kind of top-down evaluation of these structures to see how things are going. So it really gives you a snapshot and provides a record to make fieldwork more efficient. So here we have a 2024 and a 2025 map showing all the structures. And that resolution of these drone maps lets you zoom in and evaluate how structures are changing. So this is an example of one that had failed in the time between site visits. So this data is useful to have evidence for when structures need refilling or when they need to be extended to continue giving the benefits that those low-tech structures provide. And the longer you have this data, the more you're able to compare year after year, and that's really helpful for revealing trends. So just for a quick example, at this PAL structure, there's a large impoundment above it, and the size of that impoundment is, we're wondering if maybe the ice dynamics in that site are having an impact on this structure. So having this data set really allows you to ask those spatial questions of the site. So now I'll talk a little bit more about how drone data can be used along with GIS to track physical metrics in these sites. In 2024, researchers at Colorado State started a project to monitor and measure the ecological differences between sites where LT-PBR had been implemented versus ones that had no LT-PBR, and comparing that to natural beaver ecosystems. So as a part of this work, they needed to understand and measure these sites in a quantitative way. And it became clear pretty quickly how messy a lot of these stream sites are and how difficult and time-consuming on-the-ground surveys can be to measure the characteristics of these sites. So we used high-resolution site maps and GIS to measure channel length, total wetted area, sinuosity, and habitat types along the reach. And this data was used to normalize fish and insect data, and also included as a tool in their statistical modeling to compare these sites on a level playing field. So this paper just came out a couple weeks ago. You can scan the QR code in the top right. It's a really comprehensive review of the ecological metrics in these sites. And just a spoiler alert, it showed that these LT-PBR sites showed improved fish habitat and thermal heterogeneity, but it also points out the need for longer term monitoring to really understand how the ecology in these sites is changing as a result of restoration. So another goal of this work, implementing LT-PBR in these high elevation sites, is to reconnect floodplains. So with that goal, it's really important to understand project outcomes and make sure things are going according to plan. So practitioners want to know how much inundation is happening at high flows and which structures are most responsible. So having a low water and a high water orthomosaic allows you to trace and measure the extent of inundation on the floodplain. And this allows decision makers and engineers to see how reality lines up with their designs. And if a structure is not performing the way that they intended, it justifies adaptive management. It also, having a record of how these projects are performing, allows practitioners to take lessons into the future while these projects are being implemented on new sites. It's also a really good communication tool to show the public how restoration is changing the characteristics of these sites. So just a simple subtraction on the extent of this inundation shows that the floodplain reconnection and inundation increased by 1 1/3 football fields in just a quarter-mile reach. So that kind of helps people grasp how much more wetland habitat is coming as a result of this work. Vegetation monitoring is also a really key part of monitoring these restorations. So one goal up in the Pooter is to foster beaver recolonization in these sites, which means that there needs to be habitat and resources for the beavers to do their work. However, a lot of the willow in these sites burned during the fire, so practitioners are trying to facilitate the recolonization of beaver in these sites. But another complicating factor of that is some sites are grazed by cattle and elk. So they're implementing exclusions at these sites, but they want to know how well the willow is recovering. So having structural information from these surface models allows you to pick up the willow canopy height and then see how that age structure and size, how the size structure of willows in the site is stacking up. So they really want to see young willows getting above the 6-foot height class so that they're out of range of grazers. And on sites where they're not seeing that, this sort of vegetation structure data can be useful for knowing when those exclusions are being helpful or when they need to be adjusted. We haven't done a ton with invasive species in the Pooter work, but I thought I would just mention it briefly because I know there's a lot of interest at the River's Edge West conference. So the timing of drone flights gives a real advantage in monitoring invasive species. So you can target the exact phenologic phase where invasive species stand out compared to their native neighbors. So this figure here is an example of some work I've been a part of in the upper Midwest, mapping purple loosestrife, which is a wetland invasive. And it has very conspicuous purple flowers that pop in early August. So really high resolution drone maps allow us to pick out the flowers and then filter out all the purple pixels and have an extent map of the purple loosestrife plants. And this helps managers understand how their biological control is working on the landscape and make adjustments as needed. So as multispectral sensors are becoming more widespread, it's also, drones offer a platform for automatic classification of invasive species, and there's a lot of exciting work being done out there. And I'd be happy to talk more about that afterwards. So hopefully these examples illustrate the value of drone imaging in informing adaptive management. And this sort of data collection is no replacement for field surveys by any means, but I think it offers a meaningful support to field surveys, and it can back things up with a consistent spatial record. The value of this data increases over time. So it's hard to know when you're first out there collecting, like, how things are going to change, but having that baseline lets you come back and understand how restoration is progressing. And it can pay for itself just in minimizing return site visits. So I think there's an important cost savings there, and it allows you to take lessons to future projects and avoid costly mistakes in the future. So I'll touch now on how drone imagery can foster collaboration and public engagement in restoration. So our work in the Cache-la-Poudre watershed really illustrated to me how valuable drone data is across disciplines. So the drone data we collected for researchers became really useful for practitioners for monitoring and acting as a baseline for future projects. And then the data that practitioners collect at high water and low water is really useful for researchers exploring new questions of how this restoration is playing out on the landscape. So sharing this data really led to new ideas and a common understanding of the sites. And the same data sets kept finding new uses across disciplines. So I think it's really useful. It's most useful when this data is shared as widely as you can. And there's a lot of great tools for sharing river data, like the Riverscapes Consortium has a great data warehouse. I have experience using HydroShare for sharing data, and the River's Edge West makes their monitoring data public. So I think incorporating drone mapping into these public data sets will help practitioners across watersheds understand lessons being learned in different locations and be able to apply those to their own watershed and maximize the benefits of this type of work. And I know I touched on a lot of technical information and maybe more measurement things and how that can be useful for monitoring, but I don't want to understate the value of simple visual storytelling with these aerial perspectives. So I think just having this landscape view from a drone is really key for communicating complex processes to non-experts. And having the public understand what's happening at these sites is really key for support. And the support is really necessary to implement restoration on a scale in the landscape that will move the needle on some of these degraded systems, especially with climate change posing so much challenge in these watersheds. Just having everybody understand what's going on and how useful it is really key for that adoption, widespread adoption. So some limitations of this work, there's definitely limitations to drones. All sites are not created equal. These high elevation beaver meadows are really nice for seeing that top-down view from a drone, but in places like the Northwest where you have really large canopies, you're not going to be able to see through that vegetation and have this sort of insight. Also, elevation and wind can play a role in site selection. So especially in the afternoon, wind can be a real hindrance to flying drones in Colorado. So that's something to pay attention to. And there's non-standard data collection protocols across organizations, which limits the utility of this data, especially in those more analytical comparisons of sites. So I think we could all benefit from having a more standardized collection process. And then sites are limited by airspace and landowner permission, especially working out here in areas where wildfire might be happening. That can really shut down the airspace for large chunks of the summer and limit the ability to collect this data. So I'll just leave you with a couple takeaways. Hopefully I helped illustrate how drone imagery can provide visual evidence supporting ongoing adaptive management. Combining this data with GIS gives you a platform for quantifying physical metrics closely linked to stream health and start to pick apart how restoration is impacting the ecology of these sites. And I think drone imagery really can be helpful for fostering collaboration between organizations and engaging the public to maximize the benefit of restoration on the landscape. So that's everything for today. Thanks for tuning in. I put my contact information up here and a QR code to my website. If you're interested in talking more about drone data collection and analysis, I'm always happy to answer questions and would love to hear about what you're working on. So yeah, reach out. Thanks.